So I want to take a little bit of a break from just numeric data and talk about what we would call categorical data. And this is where we get into bar graphs. Now, a bar graph, it's going to look like a histogram. It's the same idea, except instead of having numerical data like numerical times that we're recording, here we're counting the frequencies of, well, non-numerical data. So for a bar graph, it's going to show, and let me see, relative distribution of categorical data. And what it's going to typically highlight will highlight categories with large frequencies. So we're still adding up frequencies here, but well, we're going to use the same approach as with the histogram. Let me show you what's going to happen. So let's say this is our data. And let's say we're watching cars go by. And as they do this, what's going to happen is we're going to look for paint jobs. And this is what we notice. The paint jobs, there are red. And here, I'll make a chart here, do a frequency chart. So this is going to be the paint. And here's frequency. And let's say we have red, green, blue, and purple. So let's say we see 100 cars total. So there's, say, 40 red, 30 green, 20 blue, and 10 purple. So we're going to come up with a bar graph for this. I'm just going to write these up here so I don't lose them. So like a histogram, we're going to have a horizontal axis, except instead of having numerics down here, instead of having, say, class ranges or class widths, or no, classes, I should say, we're going to have just categories. So red, green, blue, purple. And let's say we have 10, 20, 30, and 40. Now, what's on the left? This will be our frequencies. So again, it's kind of like the histogram. So for red, there were 40 of those. For green, 30. Blue is 20. And purple is 10. So this would be our bar graph. And I want to make a change here. I'm going to do something a little different, because this kind of gives away something that's going to come up next. Let's say we did our bar graph like this. Put purple over here. Let's put red over here. So let's say this is what we do. Now, what did that change? Well, nothing. We still have the same bars with the same frequencies. So this is our bar graph. Well, the reason I made the change is that we could have easily gotten our bar graph this way. When it was in the other form, that's a special kind of bar graph. And this is when we have, it's called a Pareto graph, or Pareto chart. And the idea is that we're going to have these in descending order. So that's why you might see the bar graph with the categories switched around. So instead of this, where we had purple, green, blue, and red, now it's red, green, blue, purple. Again, this was the original graph. But someone might come along and say, make this Pareto. And this is what's called a Pareto chart. It's a type of bar graph. And what we do is we put the order of the bars from left to right in descending order. So the bigger bar is first, and then you have the smaller bars. And this is what's called a Pareto chart. So we'll move our categories around along with their accompanying bars until we get this form of a bar graph. And just a quick way to see which category has the biggest frequency, especially if it's kind of close. Like let's say it was like 40, and this turned out to be 39. It is a 79. And so let's say we borrow something here. Say this was 1. Make this, and that's 20. So if this is a Pareto chart, what this would tell us is that even though it looks pretty close, if it's a Pareto chart, the highest frequency category, red, is going to be on the farthest left, or the highest frequency category will be on the left. So it's just a way of organizing your bar graph. All right. Now, another way of expressing this data is through something called a pie chart. So I'm going to use the same data. Let's say we saw 100 cars, 40 were red, 30 were green, 20 were blue, and 10 were purple. So what we do is we arrange this in terms of, well, percents or proportions of a circle or a pie. Now our total, let's take a look at our cars, and let me write this out so you can see it. So there were 40 cars that were red, green, there were 30, blue was 20, and purple was 10. And then the total comes out to be 100. So if we turn these into percents, what we get for red, you take the amount, and with a percent you divide it by 100, or the total in this case, I'm sorry, not the percent. You divide by the total, and then you multiply by 100%. Now in this case, by coincidence, we have 200s here. It's usually not going to happen. Your total is usually going to be something different, but you always multiply by 100%. I mean, this could have been like a total of 300. Doesn't matter. You would always multiply by 100%. But if the total is 300, you would divide by 300. And what you'll get is 40%. Same with these others. So these are the percents. So what we can do is, these are percents of the area of a circle. Now, the way we do this is we don't just take random chunks of the circle. We don't say, okay, this is kind of 40%. That's not how we do a pie chart. We create slices. So we find the center of our circle. It's right about here. So I'm going to eyeball this a little bit. So 50% would be down the middle. So I'm going to come up with a 40% slice first. So this is half of it, 50%. So this would be 25, 25. So maybe it's easier to do it this way. I'm going to try to divide the periphery into 5 segments. Say 1, 2, 3, 4, 5. This one's awfully big. Try this again. So we go put these little holes back. Let's say 1, 2, 3, 4, and 5. So that looks pretty good. So these are of equal length here. And here's my thinking. If this is 50%, each one of these is 10% of the half circle. So I'm going to do this. So there's, am I missing one? Oh, we got it. So 1, 2, 3, 4, 5. This is 50%, so 10%, 20, 10%, 10%, 10%, 10%, 10%. So for 40%, since this whole thing is 50% or half the circle, and these slices are roughly the equal size, and there's 5 of them, I only need 4 for my 40%. So I'm going to put 40% red. Now, let's see here, 30%. Well, we know this is, one of these slices is 10%. I could do the same thing here. Say here, here, here. Gosh, that doesn't look right. Maybe that wasn't 10%. Well, we're going to have to do it best as we can. 2, 3, it's 50, 4, and 5. That looks pretty good. These are roughly, very roughly the same. So there were 4 slices here. There's 1, 2, 3, 4, 5, 6 slices. So 3 of these, or 30%, will be green. 2 of these are 20% blue. And then 10%, or one slice, it's going to be purple. So this would be our pie chart representation of what we did using the bar graph and that we turned into a Pareto bar graph. And you could use percents here, or you just use frequencies, but percents help. But you can also see very quickly what's going on. You can see which category is dominant, and you get some idea of the distribution. Now, in this case, with distribution, you're just seeing really which category is bigger than the other, or if they're the same size or close to the same size. So that's our pie chart. Any questions about this? Let me know.